So we're going to be going through Docker and containerization. So can anyone kind of tell me what they know about Docker and containerization or anything that they've learned about before? Maybe you've heard of it or you understand it from another place, but can anyone give me like a definition of what Docker is and what is containerization?
Is containerization putting an app and all its dependencies and requirements within a container?
Yeah. But what problem did it solve? You said it containerized. It's putting an app into a container, right?
Yeah.
With its dependencies. What does that actually mean?
Like, for example, if you don't have a certain dependency on your computer, it'll install those dependencies so you can use that app. So if you, for example, don't have Python 3.2 and that's required for the app,
Okay, so how was it? Another question. How was it done before the the existed? You have the app, you have the application, and you said, for example, it needs Python, mm, say Python 3.1, 3.11, yeah?
yeah,
But then the server might have Python, let's say 3.9. What's the issue here? There's a what issue? Which one breaks and which one works?
the app breaks.
Nope, the server breaks.
Oh,
The app is the one that's supposed to be working. That's where the application works, right? But what's the issue? There's a dependency
yeah,
mismatch. Does everyone understand? Does everyone
yeah,
understand? Yeah, so there's a dependency mismatch. So basically, this is all to do with the environment. Yeah? What we're describing today is the environment. So containerization and Docker and everything is not really how the application behaves. It's about the environment that the application lives in. Remember we discussed last time, there's three types of environments. Can anyone remind me what the types of environments were? We said development was one of them,
live production,
production, you say, and then what was the other one?
UAT,
UAT, and then there was one more,
staging,
but
the
sorry,
staging area.
staging.
staging the environment. So basically, this is the classic pain point. Before containers, deploying a software into production basically was a complete nightmare. So people used to say, oh, it works on my machine. Developers would build the app on their machine, hand it over to the cloud team or DevOps team, and their application has 3.11. So in their local machine, like their laptop or PC or whatever, they have the Python version 3.11. Yeah, some other libraries and etc. Whatever operating system configuration. Yeah, they hand it to the operations team, which is either the DevOps or the cloud team. Then they hand it over. Whoever's deploying on the server doesn't have the same dependency or version of whatever dependency, whether it's the language or anything else, everything in the environment. So the bug is not inside of the code. The bug is actually in the environment. Does that make sense? The containers basically solve that problem by packaging the application and all of its environment together in one go. So this is what the new solution would look like, yeah? So this is before Docker, this is with Docker. This is with, show you how it solves this solution, solves this problem, sorry. So before you even have the application or the server, what you have is first a container. So think of this as like a shipping container. You guys have seen a shipping container before, yeah?
Yeah.
Yeah, shipping container. The shipping container has the application, which is needed, obviously. Mm. And then it has the the application as well as the language, whatever for this example, we'll just say Python 3.1. And then we say also it has certain other libraries. So these are all the other dependencies, yeah? Whatever dependencies there are for each application is different. You know, the dependencies for a mobile app is different to the dependency for a desktop app. You have to be a little bit careful with not confusing the dependencies and the libraries. And then also the operating system as well, because obviously applications don't run on a single operating system, right? They run on Windows, Mac, whatever operating system. Therefore, what happens is all of this is packaged into a container. Yeah. Imagine this is make this square. Imagine this is the shipping container, and you ship it across everywhere. You package it once, you run it anywhere. That's the entire solution. What Docker solves. Any questions so far?
No.
Right. Now, here's what I'm going to move on to next. So, we're going to talk about image versus container versus registry. Can anyone tell me, or has anyone heard of these terms before? So we talked about what container is, but maybe image and registry might be something new. I don't have any idea what these terms mean, because this is the most confusing part of this topic.
An image is inside a container, and a
Okay.
container can be stored in the registry.
Okay. Can you explain what it means by an image is inside the container? What does that mean?
Hmm. The image is like the app itself with all its dependencies.
Okay. So we say, yeah, that's I see where you're coming from. So an image is essentially a blueprint. So what does this mean by blueprint? So essentially, it is a frozen snapshot of an entire application plus all of its environments. So think of for example, has anyone studied object-oriented programming? Or do you guys know what object-oriented programming is?
No, I don't know this. No.
Okay, we'll go for
No.
another topic.
No.
Let's think about like from a real analogy. Okay, so let's say a recipe in a cookbook, or like no, yeah, let's say a recipe in a cookbook. Yeah. So what's that recipe? What's the purpose of the recipe in the cookbook? Purpose of it.
It gives a step by step
Thank you.
instruction to follow.
Yes. So it describes, yeah, what something is, but it doesn't do anything itself. So it basically is describing what the application is. It's like the blueprint, basically what the application is, but it doesn't do anything itself. It's just like the rule of like the rules of what the application would be doing, etc. Yeah, does that make sense? Does that
Yeah.
make does that make sense for everyone? Is anyone confused about that?
Can you
So
explain
this
it again, please?
so when we describe something as being a blueprint, what I'm basically saying is it's basically a snapshot. So one way to think about it is it's a snapshot of the entire application. When you take a snapshot of something,
Okay.
you're basically saying like this is the evidence of that app. Like for example, if an application is main goal is to serve as an e-commerce application, obviously there will be things that uh, you know. actions that you would take on the application, like for example, how to run it, how to do certain tasks. And if any of those rules are broken, then it defeats the purpose of the app. Does that make sense? So it's like
Yeah.
think of it as like a recipe. You say, I'm gonna make banana bread, and the recipe is instructing you to make a carrot cake. I don't know, for example. It's completely different, right? So it's the image of the container is basically describing what the application is, what's its environments are, what it were, for example, if it's dependent on a Python or Java or whatever programming language, what libraries it's dependent on, whether it works on a Mac or Windows or whatever operating system it should work on, etc. It's just telling you what the application and all its environments. Does that make sense? And it's a
Yeah.
read only.
Yeah.
It's a read only. This is
Mm.
very important for you to understand. An image is only read only. It doesn't really serve the purpose of like, it doesn't run anything. It's not supposed to run anything. It's just read only, yeah? And this is good for engineers because you get to see what that container, because you're going to be seeing like hundreds of containers. You'll basically know what that container should be doing, yeah? Okay, a container then. Can someone describe what the container is? So if I said the blueprint, the image is the blueprint, it doesn't really do anything. It just tells you what it is. What is the container then?
Container
Is it a
should
bucket?
be a container is everything that it's kind of everything in the app that need to work. So like it's something like what you need for something to prepare. Like, for example, if you want to prepare food, everything you need to make that thing work. That's something that's
No,
what I love.
you're describing an image. You're describing an image. Again, think about it. You're describing the recipe. Everything you need, you said.
Yeah.
That's the recipe. That's not really a container, is it? That's what an image is. You described what an
Oh,
image is. So an image is everything you need to run the app. So remember, that's what I mean. That's what I was trying to describe here. Yeah. But then after, let's say you have everything you need to run the app, what then would you do? Like if I told you, um, you know, the recipe, I'm going to give you a recipe, and the recipe has everything, all the ingredients that you need to actually make a banana bread. What then would you do next?
Put it in the container or
yeah,
bucket.
the container.
Build it, yeah, to actually bake it. Do you get it? So the container is the next step after you have the instructions of what you need, what environment, etc. You then actually have the recipe, actually run basically make it. You get it? Does that make sense or not?
Yeah, please. The container and bucket, what is the difference?
So what you're trying to describe is like a container is a self-contained box that includes
Yeah.
uh, everything image needs
Yes.
to need to work.
Exactly. Yeah. So basically,
Uh,
the container is the live thing. Like you need So if the image is the recipe, the container is the actual thing that you make. So
okay.
when you have the recipe, the image is the recipe. It's telling you like what environments, etc. And the container is actually running it, basically creating the actual real live thing. Does that make sense?
Yeah.
Yeah. So the container is the cake that you actually bake. Yeah. That's what it is. So if I said right now I had one recipe for you, does that mean you only create one cake, or can you create as many cakes as you want?
With more than one cake per container.
Yeah, that's a little bit confusing. You said more than one cake per container,
More than one cake per container, as in like more than one image per container.
more than one image, correct? Yes, exactly. Does that make sense for everyone else? So you have one recipe, but you can have as many containers as you want. Basically, you have one recipe to make a cake, for example. You can bake as many cakes as you want, right? But then they're completely isolated. Yeah, so not all of them will be the exact same. They're from the same image. Yeah. So one image. Does that make sense? One image, but different versions of that image. Yeah. Because obviously they'll, if you're baking a cake, it will be all tasting not all of them will taste the same, right? It's the same way with applications. You have one image, but not every application will run the same. They will run the same as in they will have the same ingredients, but meaning they're isolated from each other. Yeah. So they won't be running um, all from the same host. Okay? Does anyone have any questions? Wait, Augustus, you said you had a question, something about Docker versus container.
Yes, please.
Oh,
Con-
what do you,
Container bucket.
right? Can you repeat that
Bucket.
question?
What is bucket and container? Is it the same thing?
So you're asking what is the difference between Docker and the container? Is anyone
Bucket and container.
bucket, you said, or Docker? Sorry, I can't.
Bucket.
Bucket.
Yeah.
We're not referring to a bucket here. Is
No,
what?
the container. Can we refer bucket as a container?
No, we're not referring to a bucket here. We're just saying container only.
Okay.
Yeah. Okay. What about registry? So registry is the last one. So again, so now you have the recipe, you have the live thing. Okay, now what's next? So what does registry mean? Registry. 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 What does registry mean?
Where you store your containers.
Where you store all your containers? So yes, it's like a storage or it's like a storage or a distribution service, yeah? Yeah. What does this mean? So anyone guess what's this mean? Why do we need to have a storage or a distribution service?
For easy, okay, for accessibility.
Thank you for accessibility. So again, let's go back to that recipe example. If you had that recipe that I gave you, imagine I gave all three of you a recipe, yeah? And I told you that's the only copy I have, right? Do you follow? You would try to keep that copy safe, right? You would store it somewhere, right? Yes or no?
Yeah.
Yes, so that's the whole idea. So Docker images are stored in something called a registry. So basically, this distribution service is only for images, yeah? So this is something important to understand because the image is what tells you what the container should have. Does that make sense? The image is the most important part, yeah? Because how can you have a container or have something live without having a blueprint of what you need? Does that make sense?
Yeah.
So you need to have the image saved somewhere called a registry. Yeah. So it's like, for example, there's one called Docker Hub. We have a one Docker Hub. There's something called ESR, ECR, sorry, ECR, Elastic Container Registry. So this is Amazon's AWS's like version of it. ECR or Docker Hub. Basically, you push the image to a registry, yeah, and and you pull them down. You push it up, and you pull them when you need it. Does that make sense? To create a container. Does that make sense? So the recipe that you have, for example, an application might have, I don't know, like 10 dependencies, you know, two operating systems and 50 libraries that it uses. You push that into an image, that image gets pushed into a registry, you save it. Yeah. It's a read only, by the way. So you will only be able to read it. You won't be able to edit it or anything like that. And then once you pull it, you use that to create a container and then you push it back to the registry. It's like a safe, basically, place to keep the the image safe. Yeah, because if you lose it, it's dangerous. You won't be able to even create a container at all. So it's like very important for you to have an area, a space where you can save the um the image. So just I want to pause here. If I have one image, how many containers can I run from it? And this is a question I asked earlier about a recipe. If anyone remembers, if I have one image, how many containers am I able to run from that image?
It's not, it depends on how you want to produce the image.
Okay, is there any other answer? Let me repeat it one more time. I have one image. How many containers can I run from that image?
One container.
Are you sure?
Because you
If
can
I
run. I
let,
think you
let
can
if I said to you right now, look, let me make it as simple as possible. If I said to you, you're gonna hold a party for 100 guests, okay? Okay? Let's
Yeah,
listen to the
yeah,
scenario. You're gonna have a party or gathering for 100 guests. I said to you, the task is you have to bake banana bread. I give you the recipe, yeah? And I said to you, you need to
yeah,
bake a banana bread for all 100 guests. Every single person has to have one banana bread, yeah? The recipe
yeah.
is one, right? You have one recipe. Are you gonna have 100 recipes for each person?
No,
Why does that not make sense? Is that like a bad solution, a bad, way to go about it? Why can't you have one recipe for each person and use that recipe to bake each person a banana bread? Doesn't that sound a bit ridiculous and time consuming? Does that make sense now, or still a bit
It
confusing?
makes sense. You use the recipe to produce 100 breads
Exactly, but
or
you,
100.
the container is scalable, right? Meaning you can build as many banana breads as possible, right? From
And
that
then
one
put it
recipe.
one.
Does that make sense to the rest of you? Hope that makes sense because this has to be set in your mind, like you know, before you move on to the next stuff. Because it's important for you to understand what these terms mean and how they actually come together. So the answer is you can build as many as you want. So the container, you can build as many. That's why containers are scalable. Yeah. That's why containers are scalable. You can ship it as many times as you want. Yeah. Okay. Any questions so far about any of these terms, or anything that you um, want me to clarify? No? Yes? So now I'm going to go through something called a Docker file. So Docker file, again, I'll ask, so has anyone heard of what a Docker file is? Docker file? Anyone heard of a Docker file?
Yeah, no heard about
Yeah, I've had it in AWS.
Yeah. So a Docker file is essentially a, just a piece of a text file. So it's a TXT file, and it's the instructions that's used to build an image. Okay, so it's the recipe written down. Okay, I'll walk through you an example of what a Docker file looks like. Yeah, just a minimal example. Then maybe you'll get an idea of what future Docker files you. So I'm gonna write. I want you to kind of guess what I'm doing here. What each line means. Yeah, to understand or guess what each line means. Can anyone guess what I'm doing here? Just a guess.
Recipe, recipe guidelines.
But what am I doing in each line?
There's different topics, procedure.
Any other guesses? So 6 lines, yeah?
Yeah,
So basically, the first line says from Python 3.1 dash slim. Yeah?
yeah.
So what does this
Reference
line, what do you think this line is doing?
referring us to Python
Yeah.
3.11.
Yeah. So this is the language dependency, yeah?
Mm.
And then so I said work dir / app. What's this doing? What's this line telling me to do? What does work dir stand for, HK?
Is that directly?
Yeah, work directory.
Work directory. So I'm setting the work
Yeah,
directory, yeah?
yeah,
Cool. Okay. And then this line, copy requirements.txt.
mm, yeah.
What
Copy
does
TS.
this text file have, or what do you think it has? What does
It has
requirements
the
mean?
app. It has app. The software required to run an application.
Good. So we say dependencies, yeah? So the requirements for the app. So this has all the dependencies. So if I have like packages or things installed, whatever it is, like this is where that text file will have it. So I'm copying that text file. Yeah. And then what's the next thing I do? This is pretty self-explanatory. So once I copy them, then what do I do?
On
You are installing the
Installing what?
I think you are running. You are running the. You are running that installing that application
Not the application. Not the
or
application.
the okay. You the content of the um. You're doing installation anyway.
Installing what exactly?
The test file.
Nope. I'm highlighting here. I'm
Okay,
install
dependencies.
Thank you. I'm installing the dependencies. The requirements.txt file has the dependencies. I'm
Yeah,
then running this pip install requirements. So I'm installing all of the dependencies in that text file.
yeah.
Yeah? Does that make sense? So first I copy and then I install the dependencies. Yeah? Do you follow now? So I copy and then I install the dependencies. This one might be a little bit unclear because you're thinking, what does this full stop mean? Basically, I'm
Copy
copying the
all.
sorry?
You're copying everything, all the dependencies.
Good, thank you. I'm copying the application now. So I'm copying the app code. Yeah.
Yeah.
So here's a question for you. Why do we need to install and copy the dependencies before we copy the app? Azhar, the question is for you. Why is it not the other way around? Why do we copy the app first and then install the dependencies? What's the issue with that?
Um, the dependencies, so it's guaranteed that the dependencies get attached to the app. Um, that's my reason.
So the dependencies are what? Sorry, you said
Get attached to the app.
get attached to the app.
Mm.
Okay. So
As in,
when yeah, go ahead.
once we put the image in and we install dependencies, but we install it within the app environment, so it install within the app.
Yeah. So imagine I install the app and then it crashes because I haven't got the dependencies
Mm.
sorted first. Does that make sense? So when you're setting up a container, you have to copy the requirements, which is the dependencies, then install the dependencies, and then copy the app. So the dependencies are already like set, it's already installed. Does that make sense? Yeah.
Mm.
And then the last line is basically what to run, yeah, when you start. So what do you run? We run Python and then app.py. We just run that, or the terminal runs it, yeah. So this is an example of a Docker file. This is what a Docker file is, which is essentially the written recipe. Every instruction creates a layer, yeah? So the layers stack on top of each other to form the final image. So this is what an image is, yeah? So Docker file is essentially the written version of the image, basically the recipe, yeah? You're telling each container what it should have. Now, I want to talk about something important. So caching is very important here. So, does anyone know what is a cache, or what does cache mean? Anyone heard of that term before?
Yeah, but I've forgotten.
Take a guess, or does anyone have an idea?
Uh, I think a cache is like bunch of data.
I think cache picked up all the dependency required for the application to run smoothly.
Okay.
For example, if you're going to a website, so the um, it's a software they use to capture key ingredients they require to make decision.
Not quite. When I say I'm caching something,
You are picking necessary information, relevant information.
This is something paying.
okay. So when I say cache, I basically mean it's like a um, memory, like it's like a quicker access to memory without having to go to the RAM. Yeah?
Okay, yeah,
Yeah?
yeah, get it.
So it's like saving something temporarily without having to go to, it's like a place or a storage area where instead of like going to the main, like maybe the short-term memory, which is the RAM, or go into the hard drive or the long-term storage, you can go to the cache and it has your data already pre-stored. So, for example, in terms of a recipe, let's go back to the recipe analogy. You have a recipe, right? And you're going through the recipe. One of the things in the recipe is, for example, I'm going to give a random example. Let's say you're chopping onions. You chopped an onion, yeah? You chopped half of the onion. What would you do with the other half? Would you throw it away?
No,
Where would that go?
reserve
Where would it
for
go?
future reference.
Where would the onion
You
go?
can put it there. You can storage.
Where?
Temporary hold. You can make a temporary holder. You can put it somewhere temporary, maybe in the fridge,
Yeah,
so
yeah,
you can use
okay.
it. And you can use it.
Thank you. So put it in the fridge. Maybe tomorrow you might need to chop onions again, right? Do you understand? So this is imagine like that recipe is in a Docker file. For example, any of these steps, right? First, what Docker will do is it will check the cache in case, for example, if I install all of the requirements first time, you know, and I saved it and I check it again, nothing has changed. Do I need to reinstall everything? Do I? It's already there, right?
No,
Is that, who said no? Someone said no.
I said no
Why would you say no?
because it has a backup.
Surely it's a yes, not no, no. I'm confused. You said it would be a no,
Yeah,
but then why is it a no? I'm
well,
asking you.
it's already in the file. So
Exactly. So
that
it's a yes then. So it won't have to reinstall everything, right?
yeah,
So it's a yes. So it won't have to reinstall everything. Yeah.
okay.
So
That's good.
it skips this step. For example, mm, it does step one, does step two. This is the first time. Yeah. Imagine the first time. Does step three, does step four. All of this, by the way, is saved in the cache. It's saved in the
Yeah,
fridge, for example. Yeah. Because you've done it once. Does step five, does step six. If I build another container, I do step one again, do step two, do step three. Oh, I check the cache. It already has the same requirements. So what do? I just basically use that same requirements. I don't have to reinstall. So what happens is I skip the installing because I already have, right? I don't need to reinstall everything. Does that make sense for everyone?
Yeah.
yeah,
So I don't have to reinstall it. That's what I mean by cache. It basically saves it locally mm, in the cache, in a Docker cache. Docker will cache each layer. If the application code would change, obviously the application code will always change because it always gets upgraded and improved, right? If the application code changes, mm, then it doesn't matter. But the installing the requirements, that most likely won't change. Okay? Any questions so far? So how does the layers go? So you have now how does this turn into an image? So we have the Docker, and then it goes through something called Docker build. So you build that file. When you build that file then becomes the image. Yeah? Does that make sense? So first the file is created, then you build it, then you have the image. Yeah?
Yeah.
Does that make sense? Now
Yeah.
let's connect everything into the full life cycle. So you have the Docker file, which is the recipe. Okay? Then the Docker file gets built. So it goes through a build, which then creates a Docker image. Okay? And then that Docker image, which is the snapshot, gets saved where? Do you remember where it gets saved?
In the cache
Image itself, where does it get saved? What did we say earlier?
container.
Oh, where does it get saved? Saved.
In the cache
Nope. Guess again.
container.
It- It's not the cache.
In container.
Nope. The answer is somewhere here.
Register.
You said registry?
It's not in the Docker file.
Yeah.
Registry. Why is it a registry? What did I
When you
say?
use
What did I say about a registry? If I have one recipe, to keep it safe, you would store it somewhere safe, right?
yeah.
So the registry is the storage or space. When you build it, so you have the Docker file, you build it, it makes a Docker image, snapshot gets pushed to what we call a Docker hub or ECR, yeah, which is the registry. Does that make sense? Docker
Yeah.
hub or ECR. ECR is AWS. Yeah, AWS is service. Yeah, does that make
Yeah.
sense? So it's saved into a registry. Cool. And then you run it. When you run it, it then becomes a container. Yeah, run, and then that turns into a container. And that container gets then shipped. Yeah, makes sense. Does that make sense for everyone? So that container is the running version of the application. Okay. So when I wanna pull, let's say I already have a Docker hub inside of the registry. If I want to pull from from that Docker file, there is also pull it, pull an image from there. So I imagine you join a company and you join a team, and that team already has multiple Docker files. They have it saved in the registry, right? All you'll do is you'll pull it from the registry instead of creating a new one. Does that make sense?
Yeah.
So you'll just pull it from the registry if it exists already. Yeah? And you do that through something called Docker Compose or Docker Compose, yeah? You'll learn about these terms properly later on, but just try to understand the big picture. So Docker file, yeah? Docker build turns the Docker file into okay, what did it turn it into? An image. Good. And then when I run that, it turns it into makes a
Container.
Container, thank you. If I want to save that Docker image, I do what with it?
Go to
Sorry? What do I do with it? If I want to save a Docker image, what do I do with it?
go to the cache.
Not cache. Augusta, I want you to remember it's not cache.
You go to the registry.
Registry, Docker registry, yeah? It's a Docker registry. You say Docker Hub or ECR, yeah? So a registry. Okay, if I want to pull from that registry, then I use Docker Compose. This is the command that you use, yeah? This is the command. By the way, so this is the entire workflow. So a developer will write the Docker file. It will build the image locally there by running it as a container. Once it works, then you push it to the ECR. Yeah? The production servers pull it from the ECR and run it. Same image, same everything. Does that make sense? Does anyone have any questions about this? Does anyone have any questions? Now, okay, now I'll ask a few questions. Mm, So the first question I want to ask is, what is the purpose of a registry? What is the purpose of a registry?
It's like a repository where um, files are kept.
What file specifically?
Image.
An image, yes. Docker image is kept. Yeah?
Okay.
Why does it need to be kept there? Why do we need, what's the purpose of having a registry? Like, why do we have to have it? Can we just save it locally and then just run it every time? Do you understand the question? Why do we need, what's the purpose of having a registry?
To save the
Sorry?
to save.
Sorry, I didn't catch that. Save something. You said save. That's all I had.
Yeah, to save the image
Why do we need to save the image?
for more production. Or when you are building,
Okay.
it's like a recipe.
But why do we need to save the image? Does anyone else can
For
anyone
future.
or what? Sorry, I
It's
didn't
it's
catch that.
uh, it's like a temporary storage that images could be accessed when there is need to use it.
Okay. But it still doesn't answer why. You're telling me what it is. I know that it's a storage. I'm asking you, why do we need to have a storage space for the image? Do you understand
I
what
think
what I'm asking? The
He,
and you
he
said
said it
something.
for to be reused.
Thank you.
So
For
you,
what
you
exactly?
want to use.
To be
Sorry,
reused for what exactly?
for our application.
Production.
What do what do we
To,
build from the image? Like,
to,
okay, we
to
have the
create
image.
to create other containers.
Thank you. To create a container. So a container is something that like it's like a real life container. Like you ship it as many times as possible, right? The same container is used to ship many things, right? But what's inside the container is the important part. That's the thing that you need to save somewhere. Okay. Also, one of you said it's a temporary storage. That's not correct. Registry is not temporary. Not cache is temporary. Cache is like a short-lived automatic storage, yeah, which gives you immediate results without having to actually go far to fetch the data, yeah, from memory. Okay. Registry is a long-term storage, yeah. And think of it like GitHub. When you go to GitHub, you create a repository. Um, when you push code up there, your repository will always exist. Does that make sense? So it's not temporary. It's actually permanent and long term. Does that make sense for everyone? Does everyone understand the purpose of a registry?
Yeah.
Oh, the purpose of it, just to reiterate, is to distribute multiple images. Sorry, distribute an image to multiple containers where the containers can scale. Yeah, it's lifetime, meaning it's permanent until you delete it, and if it disappears, then literally, you have your entire container gone. So if you lose that recipe to, for example, the dependencies, etc., then you have to build it from scratch again. Like it's just gone. Yeah. And where does it live? It lives in the cloud. Yeah. It's accessible to everyone, obviously with correct permission. Yeah. I think just to make sure like you don't confuse registry with cache. Registry is basically where all your finished images live, so you can share them and deploy them, with many containers as possible. Is basically where you get immediate work that's stashed that you don't have that you need immediately. For example, if I run this requirements.txt file, which has like multiple dependencies, yeah, I don't have to install this dependencies again. It might have like thousands of dependencies. Instead of installing thousands of dependencies, I could just go to the cache and pick up the ones that are already pre-installed. Yeah, so that's why we have a cache for that. Okay? Does everyone understand, or would anyone would like me to explain again? Does anyone would like me to explain one more time? Hey, Dan.